Hi students, this is the video that's going to describe how to work on processing activity 2, the first part, where you're supposed to make conversions with metric measurements. So I'm going to go through an example and explain the stair step that you'll use. Hopefully this is familiar from last year, but try and follow along, and if you need to take notes, that's a great idea. Okay, so you notice behind me, and I know there's a little bit of glare on the screen, but I think you can still see it. Here's the stair step, and the letters we put in here make that sentence. King Henry died by drinking chocolate milk. And for those of you who've never heard that before, that's just a sentence that helps us remember prefixes. You may remember that when we learned how to use a fire extinguisher, we used the word pass, P-A-S-S, and we made each of those letters stand for something. That's similar to what we're doing here with the sentence, King Henry died by drinking chocolate milk. It's just a silly sentence. We don't care who King Henry was. It's just a silly sentence that helps us remember the prefixes that you need for the stair step, because K, the K in king, stands for kilo. And the H for Henry in the sentence stands for hecto. And the big D stands for deca. B stands for base. The little d I've drawn stands for deci. The C stands for centi. And the M stands for milli. All right. There is a place in the video on your notes section that talks about the base unit for mass and volume and length. I've written them here, but you should understand this. So look at the video on your notes page that talks about what this means, so this makes more sense. But you have to figure out what you're measuring first before you know what your base unit is. So the very first question on your worksheet, and you can do this with me, is this one. So let's see if I can get a little bit closer maybe. Okay, so this says 0.893 hectograms equals blank milligrams. So you're supposed to convert from hectograms to milligrams, and it's really easy because you're just going to move the decimal over. But before we can do that, we have to figure out what this is. What are we measuring if we're measuring hectograms and milligrams? What are we measuring? Is it volume, length, or mass? Hopefully you see the word grams in there. Grams in milligrams, grams in hectograms. That's your clue. We're measuring mass. That's what this is about. So now when I look at all of these prefixes, now it makes more sense. It's kilogram, hectogram, decagram, and this is just gram. Okay, so now let's do the problem. Here's how you're going to do it. You're going to use a stair step, and I can put a whole bunch of the stair steps on your processing page. Use them. So the first step you do is you find hectograms on the stair step. So you look at hecto. Which letter is that on our stair step? There's only one H, so it's here. And I want you to actually do this. Put an X on hecto. All right, that's where we're starting. What are we looking for? That's the second question you answer. And we're looking for milligrams. Where do we find that on our list? Yep, it's this bottom one down here. Okay, this is our starting units. This is where we're ending. So the next thing I do is count how many steps from one to the other. So I'm going to start here and I'm going to say 1, 2, 3, 4, 5 steps. 5 steps, and then you have to think about which direction you went. So did I go that way or did I go that way? I went this direction, so I went to the right. 5 steps to the right. That's what you use the stair step for. But now what do I do to use that in my answer? Super easy. I'm going to rewrite this down here so it's easier to see. All right, can you see that? Yeah. And this is where the decimal starts, and I'm going to move it 5 steps that way. Just like I went 5 steps that way on the ladder, or on the stair step, I'm going to go 5 steps that way on my number. Okay, so here's my decimal. And when you make your little steps, make sure you're going between the numbers. You don't just do steps. That's not what we're doing. You have to do the steps we're talking about when we move the decimal place is between the numbers. So this is 1. I'm going to move it from here to here. That's 1 between the 8 and the 9. And I'm going to move it again between the 9 and the 3. That's 2 times. 1, 2. Move it again right there. That's 3 times. Now what? I still need to move it. So I'm going to add a 0 and move it again. So that's 1, 2, 3, 4 times. How many times do I have to move it? 5. So I need 1 more 0. I'm going to do that. Okay, so you do this, but this isn't your answer. You have to rewrite it in the correct form. So if the decimal place is not there anymore, but it's over here, my answer is 89300. 89,300. What about that 0? Do I need to put that 0 out front? Do any of our numbers actually start with 0? Only if they have a decimal place. This one doesn't have a decimal place anymore, so we have to get rid of the 0. Okay, I'm going to pause this and erase what I've done and put one more example up. Stick with me. Okay, students, I'm back, and I erased the work we did on our last problem, so I put another one up here. So look closely so you can see this. I know it's a little bit light, but it says 160 millimeters equals how many meters? So before we move on, what are we measuring? Are we measuring mass, length, or meters in this problem? Hopefully you know that it's measuring length because the base unit for length is meters, and that's what we're after here, right? Important to recognize that the word meters, is actually the base unit, okay? So now the same thing. We figure out where we're starting. We put an X on the chart. So we're starting with millimeters. Millimeters is represented by the M. So I'm going to put an X over here on the M. You can see that, right? X over here on the M. And I'm after, maybe you can't see the whole thing, there we go. And I'm looking for meters. So I had my first X on the M. Where does my second X go? Because none of these other letters are an M. So what should I be using? You need to use your thinking skills and notice all the notes that are on this page. And you need to look at that the base unit is going to be different depending on whether we're looking at mass, length, or volume. So that's why we figured out that we were using length. We need to know that in order to know what our base unit is. So in this case, our base unit is meters, which is what we're looking for. So our second X is going to go at the base unit, because that's meters. Okay, so just like my last one, I'm going to start with my beginning prefix, which was millimeters, and I'm going to bounce up to the base unit, which is meters. So I'm going to count my steps. 1, 2, 3. 3 steps. 3 steps, and it's going this direction. That's the opposite of what we did last time. It's important for us to see that because whatever direction we're going on the stair step is the direction we're going to move the decimal place. All right, so let's take a look over here and work the problem. So we're starting with 160. I don't see any decimal point in this problem. It just says 160. It doesn't have a decimal. So if there is no decimal, you can add one, but it has to go at the end. It wouldn't be right to put the decimal place in the front. It wouldn't be right to put the decimal place after the 1 or after the 6, but it's okay to put it at the end. Why is it okay to put it there? Because after I put the decimal place right there, it's still 160. I haven't changed the number at all. If I put the decimal place in the front, then I'm turning it from a really big number to a super tiny number. That's not what I want. And if I put it here, then I'm changing it to 1.6, which is still pretty small. So you put it in a place where it doesn't change the value of the number, and that's always going to be at the end. Okay, so if there's no decimal at all, you add one at the end. Okay, so now I remember that I needed to bounce 3 steps, and I'm going that way. So here's my starting point, and I'm going to bounce 3 steps and always hit between the numbers. There's 1 bounce, 2 bounces, 3 bounces. My new decimal place is going to be out in front of the 1. So my answer then is 0.160. A question you should ask yourself after you do this is, does my answer make sense? So I'm going to grab a meter stick and we're going to talk about that just really quickly. Okay, so my first part of my problem said 160 millimeters. Millimeters are tiny. They're the tiniest little marks on this meter stick, the tiniest ones. So if there's 10 little tiny marks between 0 and 1, then I can say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, 30, 40, 50, 60. 160 millimeters is 16 centimeters. Right there at 16 centimeters. So now, but I was trying to convert from millimeters to meters, and this is a big meter stick. It's telling us that we're using less than half, much less than half of the meter stick. So is 16 centimeters a very small part of my meter stick? You bet it is. So it should make sense that I'm only using 0.16 of the meter stick to represent 160 millimeters. So this is going to make a lot more sense if you go through that process and try and make sense of what you're talking about. Because if you just think about the letters and don't put sense to them, then you're not going to remember how to do this and why it does make sense. Science is all about sense making, and that takes time and thinking. So there you go. Have fun thinking. Call me if you have any questions, or email me, send me a message. Good luck.